So I'm just doing a reality check in terms of the time. The next step is to do with knowledge representation. So if you look at the world here, what does the world consist of? We have data, which is no big deal. Then you have objects in this particular real world. And then you have relationships between these objects, and events are happening in this world right now as we speak. Okay? In other words, some of you are sitting there, some of you are sleeping, some of you are taking your hand, some of you are texting. Actually, some of you are reading your email. Those things are happening. Okay? So the events, okay? There are events which are happening around here. So similarly, when you're walking on the road, and cars are going by, and so on and so forth. So now one of the things is that a lot of work that is being done in the Western world is focused on the objects, how the objects are represented, and what's the relationship between these objects. Now, events are very interesting because, in fact, if you go back to the Indian philosophy, there are a lot of emphasis on processes and events and how events are related to other events and things like that. So if you look at some of the social media things that are happening, you can see that there are various databases and the events are stored around here. And this is again some of the slides from Ramesh Jain, and this is the Arab winter or spring or whatever it is, where things happen in different parts. But the interesting thing around here is that if you look at it carefully, there are certain patterns here which are connected to one another, these events. And that is not really, that has not been understood very well at the time, but there are small events which actually can be aggregated together. So you have both atomic and composite unit events, and they're all related to each other as such. Okay? So now one other item that I would like to talk about in terms of the social media in the events is this notion of e-image. Again, this was formulated by Ramesh Jain. Is this just like you have an image? I take a photograph with this, and he's taking a photograph of me here. I guess you're taking a photograph of me. Okay, so he's taking a photograph. Okay, these are all pixels in there. Okay, just like that image, I can have what are known as the social images also here. What is the social image? So this is like could be a Facebook or Twitter or something like this. This is the image kind of when iPhone first came out. People were tweeting or whatever they're doing around here, and these are the activities. That's and this image is called this is an e-image, right? Event image as such, because now I go through time and then calculate across time how this image is changing as such. Just like a photograph, but it's a different kind of things around here. And then this can be used for actually marketeers to kind of say where I should install this iPhone kiosks and things like that, whatever it is. So I can do that kind of a thing as such. Again, keep that in mind. The reason why I'm showing you these things are these are different modes of representation. It's a multimodal kind of thing that is happening around here. And one of the things that that's dear to my heart is this notion of representation of this. How do you represent this world? How do you represent the objects? How do you represent the events? And ontologies are a way to do these kinds of things. And I don't know how many of you heard of the word ontology as such. It's a representation scheme, and it's actually pretty simple. What it is an explicit description of a domain, the concepts, properties, constraints on these things, and the relationship between these objects are events as such. So now we can generate object ontologies, event ontologies, and this is very useful because you can do some inference on these things as such. Now, for example, I can take again, I'm giving examples in the healthcare world. Look at the biological ontology, and I think this you probably know what this is. This is an eye of a fly, which are very popular around here. Now, this eye consists of actually a part of this small thing is called omna-TDM, the thing which I showed you. And that omna-TDM is the eye consists of a number of these things, and then it develops from the eye disc and sense organ. Now, the key thing here is that there are certain objects and there are certain relationships between these objects, and that's really an ontology as such. Okay, and then people have developed ontologies of the human anatomy and things like that. And one of the things you should keep in mind is that there's a whole spectrum of ontologies, basically which are represented by UML models and things like that to model formal logic. So depending on how much expressiveness you need, you can go from here to here. For some tasks, you can just represent around here and get away with it, and some tasks you need to do around that. So that means to do reasoning in the real world, you kind of need these ontologies, and depending on what kind of reasoning that you're going to do, you might actually get away either with a simple kind of representation are a much more formal logical based representation which has strong semantics in there. Okay, these are some of the ontological spectrum in the again the healthcare world. I'm not going to go eliminate this. Now, one of the problems with these ontologies is the testing of these ontologies. How do you test an ontology? And that's a research area in terms of can we learn something from the UML models that I know all about? Can we gain something from object-oriented things? Or maybe there's a software. Is it similar to testing software? So testing ontologies is a nice little research area, and they have several. I think one of the problem people do is that by jury, like a jury of experts, just like you read a paper and say whether it's great or not, you look at an ontology and see whether it's useful or not. So what are the challenges around here, research challenges? So as I told you before, that this is for a smart network systems and societies kind of activity, you have to do these things are multimodal ontologies as such, because you have blogs, events, images, video, and all kinds of things. So how do you represent multimodal ontologies? Then the next step is, depending on the domain you have, like for example, if you are working in the world of terrorist kind of activities, you may have to develop event ontologies which are needed for that. If you're in the manufacturing world, you build kind of process ontologies for the manufacturing world. In the healthcare world, you develop some workflow ontologies in the physician's office and things like that. And again, these are some of the challenges. And I'm going to send your slides to you, I guess, and you can probably send it to people if you want to. Okay. The next step, once you have the representation, then you need processing part of it. You see what I'm saying? Again, going back to it, I talked about objects. Objects are related to other objects. You have events. All of representation, I got to represent the things. I got to represent the state of this particular thing. I take a picture. In Facebook, actually, they do this tagging business. You do tagging, and that's tagged is sent across to all your friends and things like that, and so on. So similarly, here I can take a picture of this room and take all the objects in this room, and I can identify who you are and things like that. Okay, but then that's a representation for the time being. And then what do you do with it? Okay, some of you are kind of really tired, maybe sleeping. Some of you thinking maybe here is a research topic. Some of you are saying, what the hell this guy is talking about anyway, okay? So those are the kinds of things going in your brain right now at this stage, okay? But then you're going to do the processing part of it. What do I do with this thing? And here is an example that could happen. Okay, for example, you're walking in New York. So you're walking and then suddenly you start coughing. You're coughing, okay? See, he's coughing. Okay. Now he's coughing, what's the problem, okay? So that's the event. He has a sore throat, and location, well, right now it's in New York and so on and so forth. And the system kind of goes ahead and does this, the situation controller does a reasoning process, and then you have this, remember the images I talked about in the before, you have those kinds of things, so you process so immediately you have an action that you need to take. And all this kind of requires, for those of you who are the old AIS or robotics people, you are kind of sensing the information which is coming across, and your brain is processing that particular information, and you're taking some actions out here. It's just actually that's what this is all about in terms of. But then the problem is not so simple, because you're talking about multimodal ontologies or representation, and multimodal kind of things happening around here, where you have feed coming in from videos, you have feed coming in with Twitter data, and all kinds of feeds are coming in here, and then you need to process that thing in a consistent manner. And the decision making here occurs at multiple levels. At the lowest level, you have some data coming in, and then you have images at a particular level, and then you have these events which are represented in a certain way, and then you have to process them different, like for example, in this here, there's a tweet, and then here is one representation, here is another representation, and there's a swine outbreak, and so on and so forth. And so that's a different representation, and you go at various levels of abstraction, from a lowest level of data streaming coming in to a highest level of decision making as such. And as you can see, there are things here and the people here, and you're connecting people and resources. So you need to kind of come up with this aggregation and composition of that events, and then you do a situation detection, and you do all kinds of alerts and queries across this particular thing as such, and in terms of the decision analytics. So what are the challenges for this multi-level decision making? As I said, there are different levels of decision making. There is a lowest control level, and there's a lot of people who are working in CPS. You can see they're solving all kinds of neat little control problems as such, but then there's more to it. There is a control level, there's a middle level, there's an executive level, and things like that. And some of the tools actually which people are using to address these things are things such as mechanism design, game theory, and control algorithms, and those kinds of things. and the mapping between these levels also becomes an interesting problem as such, both at the representational level and at a reasoning level. Again, these are research issues. People have not really solved these things. They're still thinking on those things. You might see a few papers out there, but again, it's very, very preliminary kind of work has been done. And now, this is again one representation that we also work with Japanese counterpart, and this is the Tohoku tsunami, which happened sometime few years ago. I think it's in March of a couple of years ago. And you can see that the kind of data that people were gathering in there, and this is the Twitter data. This is all in Japanese, which anyway I don't understand. So there's a lot of data coming in here. When previously I talked about representation of data, but here that lots and lots of data are coming in. Lots and lots of things are happening around here. Again, here you have to keep in mind that there is this analytics, the decision analytics, and then you have all this data coming into the thing. How do you deal with this kind of data and information deluge as such? And there's a lot of stuff going on in this big data as such. I don't know, maybe there are programs in IIT on big data. So big data is a big thing right now everywhere, and people are getting good jobs out of it and things like that. But what I think is that you have to be very careful around here. It's not only a big data, it's massive information sources and large knowledge networks, and you have to deal with all of them, and each one poses some novel problems as such. And in terms of data, you probably heard of all these things: volume, velocity, and veracity kind of, and there are 7. And again, I'll come to why there are 7 V's as such. Okay, so there are 7 of these things which people talk about, and visualization becomes a very important thing in there. We'll come back to that later on. So what are the particular challenges in there? Again, I list a set of challenges: developing algorithms for categorization, pattern recognition, statistical learning, and visualization. Some of this work is done in other fields. So you can just do the mapping from what the people have done in the mathematics area, people have done in the machine learning area, and apply to this thing. But the key thing is to applying to this field as such, and you develop efficient test mechanism. Develop and test mechanisms for analyzing multimodal information. And then we also look at standardization of these operators. There's a lot of things happening in there, as you have seen: accessing the data, aggregating the data, assimilating it, filtering it, and things like that. Again, there are no standard protocols involved in there. And then you have this building infrastructure for these large knowledge networks as such. It's just not big data, big information, and massive information, but also to do with large knowledge networks. So here is one example that we've been working with NICT. They have been developing this huge network of where you have various pieces of information: ontological, citational, spatio-temporal, and things like that. And this is with respect to the disaster management area. Then we come to the network behaviors. Because all these things are connected, it's an interconnected network systems. For example, in the Japanese Tohoku earthquake time, the networks actually failed. The information was not being passed on to other people. The Twitter data was coming because sporadically networks used to come on and people used to Twitter and things like that. So what do you do when a network fails? I'm sure that we have people who are doing research in networks. We have dynamic reconfigurable networks have to be developed and things like that. And here are a number of challenges: understanding the complex nature of these networks. And there's a whole lot of research going on in complex networks, how things are connected in various fields like protein-protein interaction networks, social networks, analysis of these social networks, what happens if some nodes fail, and things like that. So there's a considerable amount of research going on to the things, and these networks change phases, and those there's a lot of things which you can do with this network science as such. Okay. Then we have the sensors. Okay, just like you have the networks, if you have this, then you have a network of sensors. For physical sensors, it's okay. For example, like we have let's say take Mumbai or Chennai or something like that, you can instrument the whole city with these physical sensors. And these physical sensors are measuring certain things. The video sensors are taking your pictures, and the other sensors are finding out how fast you are going so that they can send you a ticket. All kinds of things are being sensed around here. Okay. Now, then there is this whole aspect of social sensors. Now, you have physical sensors and you have social sensors. Social sensors are those things which come from social media. Just like the physical sensors come from the physical devices, I have the social media, and then I have social sensing happening out there. Now, we got to combine these two things, which I call a socio-physical sensor. Again, an example in the Boston Marathon case, for those of you who are familiar, there is this video feed which came in, and at the same time you have Facebook and Twitter data which is coming in, so you can kind of have to match both these things. So you have what are known as a physio-social sensors, and there are a number of research areas around here, developing algorithms for sensor tracking and manipulation, ontologies for these sensors, identifying social sensor patterns, very, very interesting areas based on use cases kind of thing. I don't know how much data you have here in terms of this social network. I don't know how much people use these things and who gathers the data and things like that. In the United States, we have organizations like NSA and things like that who gather a lot of this data. I don't know about the equivalent counterparts around here. And then human-computer interaction. Now, with all these networks, people, devices connected together, there's this whole issue of how do you interact with the computers? How does the computer interact with the network? What kinds of human-computer interfaces? What do you have to show the people? What are the right level of abstractions? And those kinds of things will have to be designed. That's this particular thing. And so this intuitive display of information, mental models of users in the system, feedback, giving the right feedback to the users about their actions, and there's a division of labor and responsibility around here. And finally, here the architectures, which you need to design to do these whole things. And like I'm trying to kind of, what I started with something called a thing. A thing is this particular device. And then I went into this whole network concepts of both physical and social sensors going in. And now the next step is that how do you design the whole computational architecture around here? And so there's a lot of issues that you could potentially be working on. And this is one project that we've been working on called the Cyber-Physical Data Clouds with NICT Japan. This whole notion of dynamic service orchestration, and I'm going to, in the interest of the time, just kind of shift through this thing, and have a few more minutes. I'm going to summarize the thing. And here is an example that we have in the healthcare world, where you have the social media around here, and you have some sensors coming in. And then this is some of the work which you guys are doing around here, actually, okay, in terms of NLPs, ontologies, event data integration, and things like that. And you can create this knowledge bases, and you can extract the knowledge, and you can do certain interesting things on that. And for example, I'm taking the case of an asthma kind of thing. I don't know if you can see the whole thing. Here is the event. Here is a person is complaining about coughing, and it's posted by a particular person in a particular area that is DC at a particular time kind of thing. So that's a social media kind of thing which is happening. And then you have, if you look at it carefully, it's a tweet data which goes on here, and then you make certain, you try to extract certain events from all this information that is coming on. And we also have this digital library of information, like this one is actually a paper and publications. All of them are stored in this, like some Medline information and things like that are all stored in here. And again, you can map it to your favorite domain as such. In addition to that, you have real-time data coming in from sensors. This is from air quality sensor information which is coming in onto this thing. So a lot of things are coming in. And then what you do is that you can kind of actually go through this. There's a set of rules around here which says if this particular, the air quality is between, you're not able to read that, but if the air quality is between certain limits, then send an alert and those kinds of things. Okay. So then you can do a map visualization. All kinds of things as such, and then you can do recommendations of this thing. This is just an example which we kind of generated on those things. Like this kind of shows you some of the things when I showed you there's a New York case where someone was coughing and things like that, and this is how you kind of make it happen as such. Okay. Now, so to make if you want to do the future healthcare vision, a lot of things. Again, I'm talking about healthcare around here, where you have advances in healthcare technology, like the Human Genome Project, the pharmaceuticals area, medical devices, and there's a healthcare practice stuff going on, advances, and then you can see advances in computing, imaging, and information technology. As you can see, MPCDs, internet software, and things like that, and that's all the future healthcare. You can make future healthcare vision. So what you have is that you have this notion of smart healthcare with smart devices, smart networks, smart processes, smart electronic medical records, so on and so on, everything. Eventually, it's a smart planet, if you have seen that IBM ad. And I got this from Fred Osia at Kaiser Permanente, who was thinking about it. And the 21st century doc looks something like this, where there's an old person. What's happening is we are all aging, okay? We like to think we are young. So now the question is whether for 22-year-old people here think they are young, for 55-year-old people think they are young, 65 people think they are young, and so on. And everyone's thinking they're kind of young right now. So, but then, like for example, in Japan, by about I think 2050 or 2050 or so, 65% of the people are going to be over 65. Causes some problems. And then you're reaching 80 and so on and so forth. You need something like this, and the kinds of examples I showed you will make this happen as such. Okay. So finally, for some of you who have read this book called, how many of you have read the book called The Fourth Paradigm on Data Intensive Computing? If you have not read this book, just go to the Google the book, and you can get a free copy out of it. This was a guy named Jim Gray who actually, what happened was that he went sailing, I think, and never came back. But he was a visionary. He was the one who did all this work on databases and things like that. So in his honor, they came up with this fourth paradigm, which is more to do with big data kind of analytics. Okay. Now there is something called the fifth paradigm, which is the web and distributed innovation. Now the web is there, and we are seeing this already. People are working all around the globe, and there's this whole notion of distributed innovation happening here. Innovation is not at a single place, but across the globe that is happening. And it's published by a thing called Zeta Science. Then there's a sixth paradigm, and the sixth paradigm is to do with knowledge and visualization, more in terms of intelligence being incorporated in the databases, knowledge bases, and things like that. And how do you visual this information? And this is something with Ray Kurzweil has been talking about, published in a book called Singularity Press. And finally, what we have is the seventh paradigm, which is the smart network systems and societies, which is published by this thing called the World Press. By the way, only the first of this has been published. Rest of these things are fake, and hopefully things will happen in the future. As such, I kind of came up with these things, such, and that's why you have only a seventh paradigm on the thing. And actually, before I came, someone told me that there are 7 hills also in Tirupati, because there are only 7 things that can happen, and so on and so forth. Looks like 7 is a number which is of interest. So anyway, in summary, in smart networked systems and societies, they harness the power of sensors and information sources, and there's a strongly emerging participatory culture, and we have the collective knowledge and intelligence of societies. And imagine the following right now. Imagine it took about 30,000 people to build the Taj Mahal, I believe, okay? I don't know the exact number, but I believe it's 30,000. Some of them were paid, and some of them may not be paid, may not have been paid, I don't know. But this is definite. The 100,000 people have built, it took 100,000 people to build the Great Pyramid. A lot of them, I believe, didn't get paid. We don't have any accounts on that, but I don't think they got paid, especially if you see movies, the old movies, Ben-Hur and other things, and so on and so forth. You can see that. And it took about 300 to 400,000 people to put man on the moon, and these were reasonably well paid. Okay? Now imagine what can the combined intelligence of millions of people on the internet can achieve. Just imagine. Think about it. Sit back, relax, and think. Okay? Anyway, this is some of the acknowledgements around here. So the number of people working in this area, a whole lot of people were in there. Okay, so I think I am out of my time around here. So thank you very much. So again, as I said, this is a vision. A lot of research areas in here, keeps you busy. And if you are interested in working some of these things, come talk to me and we can see what we can do. Okay.
This is a nice talk. Actually, I have one query. You have shown the pyramid of 1.5, 2, and
3, okay, yeah.
3 and 2. Mm-hmm. So what is the main reason restricting the bottom part of the pyramid to add up the newer technologies? What is the main reason behind that?
There are several reasons, but what I'm saying is that that may not be true too much in the future, but there are social, political, and economic reasons. Now, since I'm being videotaped, I won't talk about the political reasons. Okay? But sometimes it makes sense to keep people that way, kind of thing. So you know what I'm saying, okay? But it will change. The societies are changing. Those people are becoming wealthier, and things will change in the future. But then what may happen is that they may not actually have these devices, but they will have access to these devices. In other words, you go to a village, and in that particular village, you can provide them access to the internet and things like that. And I think it's happening in India right now. They have these kiosks and things like that in some farming things. So it will happen.
So technologically,
that's why I said but. That's the thing.
Okay. So technologically, the challenges is to modify the existing devices,
Yeah.
or
There are two challenges here: technological and socio-political challenges around here. Technology-wise, yes, you got to adapt the technology to the culture. In fact, a couple of years ago, I organized a panel in symposia in the AAAS conference on anthropology and engineering. How can culture affect engineering, and how can engineering affect culture? So these two things go together. Like you kind of do a device, develop a device, and the device you take it to a particular culture, and you have to adapt this particular device to that culture. Similarly, the other way around, the culture gets adapted to the devices also. So both things can happen, and they're building all kinds of things with these devices right now. In fact, there's a guy in UCLA who has some kind of little bit microscope attached to it, so you can go do a blood sample and figure out the malaria, whether the person is a malaria or something like that, and that information is transmitted across. So this has got enormous implications for the Indian system, because most of our people live, most of the Indian people here live in villages, and that's the reason of the implication. In the United States also, we have issues in terms of remote telemedicine and things like that. So these devices are going to have that impact as such. They're going to monitor there, and they're going to send the information in there. And added to that, there's a lot of this mobile healthcare device vehicles which are going around in villages and things like that. And then I have a photograph. In fact, I don't have the photograph here, but I've seen one of these ambulances going to this remote village, but they have to cross a river. So the ambulance was put on a boat and taken to the thing. But then the thing is totally telemedicine out there. So the doctors were somewhere else in Hyderabad, and they were trying to do surgical procedures from giving advice from Hyderabad to this remote village in Andhra Pradesh. So the things are happening. It's a question of time.
Thank you.
Now the interesting thing is, how is it going to change the markets? But it's changing societies in a way. So someone posts a false video on the social network, and that is going to change how people are going to react. There are going to be riots, and it happened. You know what happened? So a few months ago in India, someone posted a false video of someone killing someone else, and the rest of the people bought it. Then this whole notion of trust. How do you trust this system? I don't know the answers, but I'm just telling you that you could be working on it. Okay? Yeah, Venkat.
Thanks, Sriram. Very nice overview.
Thank you.
I was wondering, of the various challenges that you described, many of them are largely implementation challenges. For example, interoperability, we need to agree on set of standards and so on and so forth. I was wondering whether you could comment on what are the conceptual challenges?
Well, yeah, that's a good question, because there are both conceptual and implementation challenges. For example, even in the interoperability area, there's a notion of syntactic interoperability and the semantic interoperability. In the syntactic interoperability, it's more of an implementation issue where you want to make sure that particular string is sent across. On the semantic interoperability, it's more of a ontological, what kinds of representations you put in, what kind of inference you do it, how do you transfer the meaning. Again, remember, these are machines, to people to machines talking to one another. So that's a conceptual challenge. That's one of them. So there are similar challenges on other things. And then on the multi-level decision making, you have all these levels of control and things like that. Again, what are the right levels of abstraction? And a lot of people here are working on control theory. I think you've been working on this control theory things for a long time and things like that. And how do you map this to the higher levels of abstractions? And now we have all this AI work which is going on, and how do you connect these two things? And I know you've been thinking about it for some time in your group. So these are some of the challenges. And there are political challenges that I don't know how to address as such as that. But the thing is that I think if you have to start small and grow big around here, and that's why I started with a single device and went to the network. And it is going to happen. Now it can happen in manufacturing. I just took the healthcare example because that's what I'm most familiar with at this stage. But you can apply this to a whole lot of things. But then again, it has got implications for places like India because of the problems of accessing, of getting proper healthcare to the rural world. And these devices are not expensive, by the way. I mean, a lot of these microscopes and things like that, they're pretty cheap. You can put them on the thing. But then there's this other problem in terms of power and things like that. But then you have power grids, transportation gates, and things like that. One of the questions that you can ask is about the onion prices in India. They went to what, 100 rupees a kg or something like that. And that has more to do, a lot of things to do with the transportation network and things like that. Some of these networks could fail. What happens if a network fails? And I think there's something called scale-free networks or things like that, and some of you, I guess, have been working on that. So something you should look into it. These are, again, things, people, networks, a lot of challenges. And again, conceptual challenge is, what is the division of labor between the human being and the computer? What kind of information you show on the computer? What kind of button you have to press? And for example, I had Google Maps on that. It suddenly disappeared. I must have pressed some button. I don't know why it happened. I can't find Google Maps anymore. So. Big user interface problem there. Okay, thank you again.